Hello everyone. So in previous video we discussed about the protection and deprotection of amines. We discussed in detail with mechanism total of 8 different methods to protect and deprotect amine. So in this video we are going to solve the practice problems based on previous video, based on protection and deprotection of amines. So if you haven't watched that video, I would suggest you to watch that video and then come to this video so that you can follow up and you can actually start solving. Okay, so the first problem today we have So this is the first problem. So I will also suggest you to, whenever I give you the problem, I would suggest you to pause the video and try it by yourself and then look for the solution. Okay, so this is the first question. So we have an amine group. So this amine group will be protected by using CbZ chloride. Okay, what is the structure of CbZ chloride? So this is the structure of CbZ chloride. So this nitrogen lone pair will attack at this carbonyl and through conjugation Cl is going to leave and the product is going to be so this is the product for this reaction. Okay, now the second question. So this is the reagent and this is what we call the benzyl chloroformate. Okay, we are using triethylamine as a base and this reaction is done using solvent as TMF at room temperature. So predict the product. So the reaction is straightforward. This nitrogen lone pair will attack at this carbonyl, Cl is going to leave and the product is going to be this molecule. Okay, now the third question. Okay, this is a carboxylic acid group. So in first step, we are reacting this molecule with this particular reagent in presence of triethylamine and DCM as a solvent and we are getting A. Then this A in presence of hydrogen palladium supported carbon we are getting B. So reaction is straightforward. This nitrogen lone pair will attack at this carbonyl, Cl is going to leave and the structure of A is going to be C double bond O and this benzyl group can be written as CH2PH. Now what is the structure of P? So under hydrogen palladium supported carbon we are going to deprotect benzyl group and we will regenerate the amine. And the byproducts are CO2 gas and toluene. Okay, So CO2 leaves out as a gas, and we are also left with toluene as a solvent. Okay, now the fourth question. So let's say I have aniline. Now this aniline, when react with this molecule, okay, in presence of base, or you can also use triethylamine, so you will get A. Then this A reacts with trimethyl silyl iodide in chloroform, and you get B. Okay, so what is the reaction? So this nitrogen lone pair will attack at this carbonyl, and Cl is going to leave. So the structure of A is so basically we have generated a carbamate. Okay, and we know the carbamate can be deprotected, can be removed in presence of trimethyl silyl iodide in chloroform. So we will regenerate the amine group. So now let's go forward. Okay, now the fifth question. So this is an interesting question. I want to convert this molecule into this molecule. So which reagent should I use? So there is going to be lots of protection and deprotection. Well, this is a natural amino acid. This is called S-serine. Okay, and this one is R-serine. This is a natural enantiomer and it is very cheap, whereas this molecule is an unnatural enantiomer and it's an expensive one. So how can you convert this molecule into this? Okay, so it's a sequence of reaction. So first we start with this S-serine. We react this with CbZ chloride in presence of a base. Okay, so this nitrogen, basically we are protecting this nitrogen with a CbZ group. So we will generate NHCbZ. Furthermore, in second step, so this was first step. In second step, we are using diazomethane to convert this carboxylic acid into an ester, a methyl ester. This CH2 group will sit here. And in second step, the product is going to be okay. So this is the product of second step. Okay, so now we have in third step, we are going to oxidize this primary alcohol using PDC in DMF. So PDC is basically an oxidizing agent, and we will convert this primary alcohol into acid. Okay, now in fourth step, we are reducing this ester group. using lithium borohydride. So lithium borohydride will selectively reduce this ester into a primary alcohol and it will not touch this acid group. And this will give rise to an alcohol group. And in last step, in the fifth step, we are basically getting rid of this CBZ group using hydrogen palladium supported carbon, and this is how you can form the final product, a R-serine. Okay, now the sixth question. So in first step, I'm using a Boc anhydride in presence of triethylamine to form A, and then this A in presence of dilute HCl, or you can also use trifluoroacetic acid TFA to get B. Okay, so the structure of A will be, so this is a Boc protection of amine group. So the structure of A is going to be okay, this will be protonated to CO2H and this will become NH Boc. Okay. In my previous video, I have discussed everything, what is Boc, how to protect, how to deprotect, what is the exact mechanism. So to understand all this mechanistically, you need to watch the previous video where I have discussed everything in detail. Okay, so this is the structure of A, and the structure of B will be, so basically we know that Boc can be deprotected under acidic media. So Boc is going to be removed using HCl or trifluoroacetic acid, and we will generate basically we removed Boc and we regenerated the starting material. Okay, see, first we protected this Boc, protected this amine, and then we are deprotecting it, so we will get back the starting material. And also the byproducts are CO2 gas and isobutylene gas. Okay, now the seventh question. So reagent is AlCl3 aluminum trichloride in DCM. So what is the product? Okay, so we see three protections. We see OTBS protection, which is a protection of alcohol group, which I am going to discuss in future. Then we have two more protection. We have acetyl protection and we have this NBOC protection. Now we know somewhere that because we studied about acetyl protection of amine, so we know that acetyl, to remove acetyl group, we need a strong acidic or basic medium. But here we have given a AlCl3, a Lewis acid, and we know that Boc, particularly Boc, can be removed using a Lewis acid. So here Lewis acid is AlCl3. So this is how we are selectively deprotecting Boc using AlCl3, a Lewis acid, and the product we are generating is a amine group. Basically we removed this Boc and we generated our amine back. So this is the product for seventh reaction. Okay, now the eighth reaction. They are using Bock anhydride and a sodium hydroxide. So what is the product? Okay, so what is the structure of Bock anhydride? So this is an anhydride. Okay, and this whole group is called Bock anhydride. So simply this nitrogen lone pair will attack at this carbonyl through conjugation. This whole group is going to leave. Again, I have discussed all this in detail in my previous video where I talked about protection, deprotection of amines. Okay, so the product is going to be CH3, C double bond O, OH. So this is going to be NH, C double bond O, and a third butyl group. So this whole group is what we call a Bock group. So this can be represented as NH Bock. So this is the product for this reaction. Okay, now the ninth reaction. Let's see, we have using triethylamine, and we are using, once again, let me use this time a Bock chloride group in presence of DMF and room temperature. So what is the product? So product is again straightforward. We are doing Bock protection of this amine, and the product is NH Bock, and that's it. Okay, now the 10th example. This time we have a little bit complex molecule. The idea is same. The chemistry is going to be the same. So this is the starting material, and here we are using CAN group. Okay, what is CAN? CAN is ceric ammonium nitrate, and we know that the ceric ammonium nitrate can deprotect Bock group. If you look closely, this is nothing but a Bock group. So what is the product? Well, the CAN group is going to deprotect my amine. Here hydrogen will be there. And we have generated amine group. Okay, now the 11th example. We have this cyclohexylamine, and we are reacting it with this 9-fluoronyl methyl chloroformate. Methyl chloroformate. Please excuse me if there is any spelling mistake. Okay, so this reaction is done under diethyl ether and a water, and we are bringing this reaction from 0 degrees Celsius to room temperature. So what is the product? So this is again a protection where this whole group, what is the structure of this whole group you need to know. This is nothing but a F-MOC chloride group. Okay, what is F-MOC chloride? So the F-MOC chloride is this is what we call F-MOC chloride, or in other word 9-fluoroanyl methyl chloroformate. So this nitrogen lone pair will attack at this carbonyl through conjugation. Cl is going to leave and you have generated NH. Basically through C double bond O, this whole group will be there. Okay, this whole group is going to be there, and this is what we call F-MOC, or in other word you can represent this as NH F-MOC. Basically you connect your nitrogen to this carbonyl and this whole system will remain the same. Okay, and this is how you can represent it as NH-F-MOC. Okay, 12th example. Suppose I have this aniline, I am using F-MOC chloride in presence of triethylamine. I am generating A. Okay, then in second case I am using a piperidine or maybe morpholine at using water at 0 degrees Celsius, and I am getting B. So find out A and B. Okay, so we just saw in previous example what is the structure of A is going to be. Well, A will be simply a protection, NH-F-MOC. Okay, now what is happening at this step? So we know that F-MOC can be deprotected using amine bases. What is an amine base? So they have used piperidine, morpholine. Okay, so nitrogen containing bases are called amine bases, and here piperidine and morpholine are acting as an amine base. So you need to know the structure of these two, and you will realize that nitrogen lone pair are acting as a base. So that's why we will be able to remove this F-MOC group, and you will regenerate NH2. And what is the byproduct of this deprotection? CO2 gas and this exocyclic compound, which we have discussed in last video. So this is the 12th example. Okay, let's see the 13th example. So we have starting material as NH3 plus, a acid group here. We have above the plane CO2 minus and behind the plane hydrogen, and we are reacting it with this group. This is what we call the allyl chloroformate. Okay, so this group is allyl and chloroformate. Okay, in presence of a base, sodium carbonate, water, 0 degrees Celsius reaction, and you are getting your product. So once again, a protection of amine. So this nitrogen will attack at this carbonyl, Cl is going to leave, and you will generate. Okay, so this is NH, C double bond O, O, this group, and rest will be the same. And if you look closely, we have generated a carbamate, we have protected amine, and what we call this group, this is what we call the alloc protection. So you can also represent this as alloc NH. So this is the final product. Now let's see the next question. So here we have starting material as, this is a question based on deprotection this time. So this is my starting material and I'm reacting this with palladium complex in presence of pyrrolidine DCM room temperature for 24 hours. So this reaction is for 24 hours. So what is the product? So we know this group is called a alloc group. So this is alloc NH. Okay. And we know that alloc group can be deprotected using a palladium. Okay. So the product is going to be, we will regenerate our amine and rest will be same. Okay. And what is the byproduct of this reaction? The byproduct is palladium will form a complex with this allyl group with heptacity 3. Okay. Now this pyrrolidine can act as a nucleophile. This is a side reaction. This pyrrolidine can act as a nucleophile. The nitrogen of this pyrrolidine can attack here and can form this group. Okay, basically this allele, this group is going to be attacked by nitrogen of pyrroline and you will generate this and palladium will be removed. So this is a side product. The main product is this, the deprotection of alloc protected amine. Okay, now the next question. So this time the starting material is okay, we have this 7-membered ring. We have carbonyl here. We have a ring here. And we have a double bond here and a pH group here. Another ring here. Okay. So what is the product if I react this molecule with HBr in acetic acid at room temperature? So what is the product? So once again, well, this HBr is going to take away this whole molecule and we will generate, first this oxygen will get protonated and then Br minus will attack here and this whole group is going to leave and the main product is deprotection. So this is the main product of this reaction. Okay, now the last question for today. So the last question is, so this is my starting material and I'm reacting it with NH2, NH2. This can also be written as N2H4. Okay. In presence of ethanol as a solvent, and we are refluxing this reaction. So what is the product? So you know that this is a imide protection, and imide can be deprotected using hydrazine to get back amine. So this particular example is of that type, where we are deprotecting this amine group. So the product is going to be basically regenerate your amine group, and this is the product. We have completely removed everything and we deprotected our amine. So this is the product. And what is the byproduct? So now this nitrogen, let me label it as 18. Okay, excuse me. Let me label it as a star group. Okay, so this nitrogen is what, star, and here we have NH2. So this can also be used for isotopic labeling, where you isotope label your nitrogen and you can track them to confirm your reaction mechanism. So this is all about the problems based on protection and deprotection. Thank you for watching, and in previous video we have already discussed everything mechanism wise in detail, and in next video, in the upcoming videos, we are going to further discuss about protection and deprotection of alcoholic group, then followed by their practice problem, and followed by basically we will see the protection and deprotection of all the functional group. We will also see for carbonyl group, we will also see for alkynes, and basically everything. So thank you for watching and hope you enjoyed it.